Alright, this is part 2 of our lesson on extending the number system. In this video, we will focus on simplifying exponential expressions like these. Alright, so we need to simplify completely, no negative exponents. When you multiply two numbers with like bases, and normally students do better at first with variables with this. So like for example, if I had n squared, times n to the 7th power, what would that be? That would be n to the 9th power. Alright, we have to add those exponents. So it will be the same thing even with a number. So please do not do 3 times 3 and put a 9. Okay? This is the same thing as 3 to the 9th power. Okay, it's just like this is n to the 9th power. Okay, and if you really want to understand why that is, then just remember 3 squared is 3 times 3. So there's your 3 squared. And remember that 3 to the 7th power is, let's see, 1, 2, 3, 4, 5, 6, 7. Whoops, I put a 7. Yeah, so that's 3 to the 7th power. But if you look at it all together, that's going to be 3 to the 9th power. You know, because there's 7 of them, and 2 of them. There's 9 of them. So they don't suddenly become 9s. They're still 3s. So it's 3 to the 9th power, not 9 to the 9th power. Okay. Anyway, looking at number 12. X to the 10th power divided by x to the 12th power. This is going to be x to the 2nd power in the denominator, and in the numerator it will be 1. Now it's harder to see with numbers this big, but for example, say if I had x to the 3rd power divided by x to the 5th power. What's actually happening is x to the 3rd power means x times x times x, and x to the 5th power means x times x times x times x times x. Now all of these things that are the same in the numerator and the denominator will cancel out. So these 3 x's will cancel out 3 of the x's in the denominator, and that's going to leave 2 x's in the denominator. Okay, so which would mean that I would have x squared in the denominator. Now really, when we're canceling, we are dividing something by itself. X divided by x is 1. So it makes sense that we'll put a 1 up here sort of as a placeholder of the numerator. So that's what's happening. That's why x to the 3rd power over x to the 5th power becomes 1 over x squared. Now it's the same thing that happened on this problem, number 12. I don't want to take the time to write 10 x's over 12 x's, but just picture it in your mind and see that the 10 x's in the top are going to cancel out 10 of the x's in the bottom and leave 2 x's left over in the bottom. That's where the extra numbers are, the extra x's. Okay, back to this. Now, when you have a negative exponent, what that means is we're going to have to take this and move it to the other side of the invisible fraction. Okay? Well, you know what? We'll do that later, because we'll talk about that later. We have x's to deal with, and we also have y's to deal with. So if you look at the x's, alright, separately, so it's like we have x to the 5th power times x to the negative 3 power. Just like we saw over here, we were going to add the exponents, like we did 2 plus 7 and got the 9. So we're going to add these exponents, 5 plus negative 3. Well, 5 plus negative 3 is positive 2. Okay, so those x's become x to the 2nd power. And then we've got the y's, and that's 2 plus 2 is 4. So this will be y to the 4th power. Okay, so I don't really have to deal with the negative right now, so we'll learn about that on a different problem. Number 14. Okay, we have 3x squared. Let's deal with that first, all right? We have these parentheses. We need to get rid of that. Let's deal with it. So 3x to the 2nd power is going to be 9x squared. Okay? You have to square the 3 and square the x. So without parentheses, it is 9x squared. So what we have is 9x squared times 4x to the 3rd power. So deal with the whole number part separately. So 9 times 4 is 36. And then x squared times x to the 3rd power is x to the 5th power. Add those exponents. Okay, so we have seen that when you multiply variables with exponents, assuming that the bases are the same, you add the exponents. Okay, so like we saw, for example, if we had m to the 2nd power times m to the 3rd power, that would be m to the 5th power because you add. So we're going to do the same thing here, but we have to add these fractions. So this is going to be m to the, and we have to do 1/2 plus 2/3. Okay, 1/2 plus 2/3 is 7/6. Okay, so this will be the same thing as m to the 7/6 power. Okay, what about this? When you raise a power to a power, you multiply. Okay, so off to the side, remember that if I had m to the 3rd power and that was squared, anytime you have a power raised to another power, you're going to multiply. So this would be, for example, m to the 6th power. So that's what's going to be happening with these a's. Okay, but first of all, please understand that we have these 3 separate things. So we have 2 to the 4th power. Okay, that's happening. But then we have a to the 2/5 power to the 4th power, and we have a to the 1/5 power to the 4th power. So all 3 of these things are being raised to the 4th power sort of separately. 2 to the 4th power is 16. Okay, now maybe you don't have that memorized. 2 to the 4th power is 16. There you go. Now again, when you raise a power to a power, you need to multiply these. So I know I'm going to have a to the something, but I have to do 2/5 times 4. Now you should be able to do this in your head because this is like 4 over 1, and you multiply straight across. 2 times 4 is 8. 5 times 1 is 5. So that's just a to the 8/5. And then similarly, the next one, again, this is just like 4 over 1. So 1 times 4 is 4. 5 times 1 is 5. So that's a to the 4/5 power. But we can't stop here. Just like on the previous problem, when we had m and m, we had to add those powers. So it's going to be the same thing here. So I'm going to have 16, and then I'm going to have a, but I have to add 8/5 plus 4/5. Okay, since the denominators are the same, we can do this in our head for sure and just add the numerator. So 8 plus 4 is 12. So this will be 12/5. Okay, so that's it. That will be the answer to number 16. Alright, number 17. I see how the x's are the same. I have x's in the numerator and denominator. So some of these are going to cancel out. the 4 x's in the denominator are going to cancel out 4 of the x's in the numerator. So how many x's will be left? Okay, that will leave 3 left, so x to the 3rd power in the numerator, because that's where the extra x's are. And then we have y to the 5th power just chilling, just sitting there. And so we don't have anything left in the denominator. We don't have to put a 1 or anything. What was that about? When it's in the denominator. We only have to do that when it's in the numerator. So that's it. X to the 3rd power over y to the 5th power. Okay, what about this one? What can I do? First of all, let me deal with this y squared to the negative 2 power. Alright, so off to the side maybe, if I have y squared to the negative 2 power, what have we learned about raising a power to a power? What do you do with these numbers? You multiply. So that would be y to the negative 4 power. Okay, so that's what's about to happen right here. So let me recopy then. So what I have is 16 y to the 10th power. Okay, and we've got 8. But right here, I'm going to go ahead and put that y to the negative 4th power. Okay, and then we have y to the 7th power. It's a lot of y's everywhere. Okay, what do you want to do next? Well, look at these y's in the denominator. Alright, can't we go ahead and put these together? Let's do that. So, remember, when you multiply two variables together that are like bases, you add these exponents. So what's negative 4 plus 7? That's 3. That's 3. So that is going to become y to the 3rd power because of that. And so I've still got my 8 and my 16 and my y to the 10th power. I'm just doing one little thing at a time to keep it clear. So now is a good time to go ahead and deal with what we got to deal with. We'll deal with the number part separately, okay, from the variable part. Okay, so the number part, 16 divided by 8 is 2. Okay, now the variable part, these 3 y's in the denominator will cancel out 3 of the y's in the numerator. So that's going to leave y to the 7th power. So that will be your answer. Okay, so that's your answer to number 18. Alright, number 19. Alright, so we got lots of choices here. Let's go ahead and deal with this denominator part. Okay, let's go ahead and do this aspect of the problem. So, if when you do x to the 5th power times x to the 7th power, you add those exponents. So that's going to give you x to the 12th power. So then we have the rest of it. So I have 9x to the negative 4 power over x to the 12th power. Now look, focus on this x to the negative 4th power. This is the first time we've had to really deal with it. So you know what? Let me give you a little mini lesson off to the side here. Look, if I have, let's say, n squared, whatever, times p to the negative 3 power, and let's say that's over r p squared. Okay, what happens is when you have a negative power, okay, so I had that, I'm just going to highlight it by writing it in pink. Okay, I had that p to the negative 3 power. A negative exponent means that this expression is on the wrong side of the fraction and needs to be moved. Okay, so this p to the negative 3 power would have to drop down here and become p to the positive 3 power once you move it. Okay, so that would move down and become p to the third power. And then you could finish the problem and this would become p to the fifth power. Okay, so that's what's going to happen here. I have x to the negative 4 power. That means this is on the wrong side of the fraction and is going to have to be moved. It's going to have to drop down. So by the way, just for the future, it would be the same thing if I had a negative that was in the negative exponent that was in the denominator. That would then have to move up. So this, if it was negative, would have to move up and become p squared in the numerator. Okay, just keep all that in mind. Anyway, back to the actual problem. This is going to have to drop down. So let me recopy so you can follow it. So the 9 and the x to the 12th power are not going anywhere. But the x to the negative 4th power is going to drop down to the denominator and become x to the positive 4th power. Okay? And then we're back to just adding these exponents when you multiply. So that's why this is going to give me 9 over x to the 16th power. So that would be my final answer for number 19. Alright, now looking at number 20. Okay, a lot of complicated things going on. Alright, let's deal with the parentheses first, everywhere. Okay, so this is in my way a little bit. Remember, when you have a power to a power, you're going to multiply. So we're going to have to multiply these together. Now, you should be able to do this one in your head, okay? You know, you've got your little backup system here, you know, with the calculator, and you guys love to use it. 2 times 2/3. No, it's not 2/3, was it? 3 over 2. Let me start over. 3 over 2. Okay, so worst case scenario, yes, you can fall back on your calculator, but and see that it's going to be 3. But you should not need a calculator for that. Alright, what you're looking at here as you multiply 2 times 3 over 2, this 2 is in the numerator, alright? It's like 2 over 1. So you really should be able to see that these 2's will cancel each other out. So of course it'll just be 3. You should not need a calculator for that. Anyway, so that'll be m to the 3rd power. And we still got the rest of it. So times 4m to the 6th power. And down here I'm going to still have my m to the negative 4th power. Now this part right here, okay, I'm going to do that off to the side as well. If I have 2m to the 3rd power, remember this is 2 to the 3rd power and m to the 3rd power. Alright, you're doing the power to both of these things. Now 2 to the 3rd power is 8. It's 2 times 2 times 2. And of course m to the 3rd power. So far we have this. Alright, now we have some choices. Alright, I mean, I see the m to the 3rd power that's in the top and the bottom. I could cancel these out right now. Okay, I mean, there's really no reason not to. Or I could go ahead and you know, combine these and then cancel later. But they're just sitting there so pretty. Alright, m to the 3rd power, another m to the 3rd power. I would just love to just cancel those out. Okay? But you would get the same answer if you continued on with the problem first. So moving on from there, so I still have 4m to the 6th power over 8m to the negative 4 power. Alright, now that we just have the single m in the numerator and the single m in the denominator, we can go ahead and do other things. Now, what did I tell you about when you have a negative exponent. That means that this expression is on the wrong side of the fraction. So this is going to have to be moved up, and when it moves up, it's going to become positive exponent. Okay, so alright, so I have m to the 6th power, that's already there, but then now I'm going to have m to the 4th power up there with it. Okay, so let's finish this up. 4 and 8. You know 4 goes into 8 evenly, but notice the bigger numbers on the bottom. So this is going to wind up being 2, but a lot of students accidentally put it on the top. Alright, technically this is a way to think about it. We are reducing this fraction, so what we're doing is we're dividing the I'm sorry, we're not dividing by 2. We're dividing by 4. We are dividing the numerator and the denominator by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. Alright, but look where it is. It's in the denominator. Okay, so just make sure that happens in the denominator. Now, meanwhile, when you multiply a variable times a variable, like bases, you add the exponent. So that's going to be m to the 10th power. Alright, now that we have something in the numerator, we don't need this 1. So we would just erase it. So we would just put m to the 10th power over 2, and that would be the final answer for number 20. Alright, let's stop this video here because that's the end of this concept. Alright, on the next video we will talk about simplifying radical expressions and going back and forth between radicals and fractional powers. Alright, so go look for part 3. I'll see you on the next video.